Hello students, welcome back to my YouTube channel Data Shop. In the last lecture, we have discussed uniform distribution. That's a discrete probability distribution. So in today's lecture, we'll be discussing certain questions regarding that. So we have the probability mass function, which is given by P of x is equal to xi is equal to 1 upon n. This is the case where in the questions you would be given the capital N or a small n, whatever you'll be taking. So there are certain conditions where the interval is given to us. So we have a general uniform distribution as well. So we'll be considering this. So a general discrete uniform distribution has a probability mass function, which is given by P of x is equal to xi, 1 upon b minus a plus 1. So what we need to consider here is that we are talking about the interval from a to b. Whereas in the previous one, your a was 1 and b is capital N. So you would notice that if I substitute the values in this formula, I will get the same answer. So B is capital N, A is 1, and the final answer that I'll be getting is 1 upon N. So the uniform distribution, you need to consider the question if they are giving you an interval, right? Like maybe 0 to 10 or 3 to 5, then you will be considering the general discrete uniform distribution formula, that is this particular probability mass function. And if they are giving you the interval like from 1 to 10, 1 to 100, then you just need to use this particular formula where your capital N is varying. So the mean and the variance would be the same, as you could remember. The mean of a discrete uniform random variable, in the earlier case, it was n plus 1 upon 2. So here it is a plus b by 2. And the variance of the discrete uniform random variable was n square minus 1 upon 12. So here you will get the same, that is b minus a plus 1 whole square minus 1 upon 12. The distribution function is given by p of x less than equals to x, which is this formula. So we have already done the mean and the variance. So you can consider the last lecture for the same. So if it is not n or 1, you can just put a and b and you can calculate the mean and the variance. It's similar and it's very easy to calculate. So we'll be considering question today. So consider this question. Roll a fixed die. Roll a six-faced fair die. Suppose x, capital X, denotes the number that appear on the top of a die. So find the probability that an even number appears on the top. Second, you need to find out the probability that the number appears on the top is less than 3. And finally, what is the mean and the variance of x? So in this particular question, if you will see, we are talking about a six-faced die. So it has the numbers from 1, 2, 3, 4, 5, 6. So first of all, I'll be considering the capital X, which is given to us in the question, that let capital X denotes the number appearing on the top of a die. So that's our discrete random variable. So X can take the values as 1, 2, 3 up till 6. So therefore, the X is nothing but a uniform distribution where your capital N is 6. So with the probability mass function, so PMF means the probability mass function, P of x equals to x, that is 1 upon 6. So the formula for the probability mass function, if you could remember, it was 1 upon n, right? So here our n is nothing but 6. So I am considering 1 upon 6. Even you can do it with the general discrete distribution. So we'll be considering another question related to that as well. So here your x is ranging from 1, 2, 3, 4, 5, and 6. So let us consider the first part where we need to find out the probability that an even number appears on the top. So as we know, the probability that x is an even number. So we only have three even numbers here. So that is 2, 4, and 6. So the probability would be the same here. So it would be 1 upon 6, 1 upon 6, and 1 upon 6. Why? We are getting the same probability because it is a uniform distribution and the events are equally likely. So the probability of each value, that is 1, 2, 3, 4, 5, 6, is 1 upon 6 only. So we will have this as 3 upon 6, which is half, that is 0.5 is our answer. That is the probability of getting an even number. So it's very easy to calculate. Now consider the second part where we need to find out the probability that the number is less than 3. So here we need to find out P of x strictly less than 3. So the number on the top should be less than 3. So it could be either 1 or it could be either 2. So whenever we have or thing, so we have a plus sign. And whenever we are talking about and 1 and 2, then we used to do the multiplication. We apply the multiplication rule. So here again, this is 1 upon 6 plus 1 upon 6. So we are getting here 2 upon 6. That's 1 upon 3. So this is the answer. Now, how can we calculate the mean and the variance? It's very simple. So we can just apply here. The mean is given by the expectation of x, that is n plus 1 upon 2. So here our n is 6. So we get 7 upon 2. That's 3.5. Similarly, the variance is given by the var x, which is n square minus 1 upon 12. So n square would be 6 square minus 1 upon 12. That's 35 upon 12. So we can calculate and it is coming out to be 2.917, I guess. So this is how we can calculate the mean and the variance given the n in this case. So this is our first question in which we need to find out all of these. Now we'll be considering the second question where we'll be applying the general uniform distribution. So consider the question. A telephone number is selected at random from a directory. Suppose capital X denotes the last digit of the selected telephone number. So find the probability that the last digit of the number in the first pass, it should be 6. Second, less than 3. So less than 3, it could be 2 or 1 or 0. Greater than or equal to 8. So whenever we are talking about greater than or equal to, so that means we are also considering 8 and as well as 9. So how to deal this question? So let us consider, first of all, we'll denote capital X. So whenever we have such distribution questions, you always need to write what is your capital X, whether it is a continuous random variable or a discrete random variable. So this denotes the last digit of the randomly selected number. So that means the X can take the values from 0, 1, 2, 3, 4 up till 9. So we have the 10 values, right? So as the numbers are equally likely, so X follows a uniform distribution where your A is 0 and B is 9 with the PMF. So now I'll be writing the PMF of the general uniform distribution. So this would be 1 upon, that's B minus A plus 1. So 1 upon B is 9 minus 0 plus 1. So that's 1 upon 10, where X is ranging from 0 to 9. So this is our probability mass function. So after this, we'll be solving the subparts. So the first part is what is the probability that the last digit is 6? So P of X equal to 6 is what you need to calculate. So this is nothing but 1 upon 10 only because it is equally likely. Then we need to find out the probability that the last digit is less than 3. So strictly less than 3. So in this we have either 0 or 1 or 2. So as we could see here, less than 3 would come all of these 3 things. So that's why we are taking their sum. So again, the probability are the same. So it becomes 3 upon 10. That's 0.3. So that's pretty easy. And lastly, we are talking about the probability that it should be greater than or equal to 8. So that means P of X can be 8 or it can be 9. Again, the probabilities are same. So the answer becomes 2 upon 10. That's 0.2. So discrete distribution is very easy. The uniform discrete distribution is very easy. And these are the 2 questions. So you can refer to that. So do subscribe to my YouTube channel if you have not done so far, and hit the bell icon to get the notifications of the new videos. So we'll meet in the next lecture.